Here we're going to talk about vector b, which has an initial point of -1, 0 and an endpoint of 2, 2. So I'm going to go ahead and draw that. In this case here, we're really going to be talking about a coordinate plane kind of. So -1, 0 and 2, 2. So initial point and endpoint. Express vector b in component form. So component form, if we were to kind of zoom in on this, we see that we have the horizontal change of 1, 2, 3, the vertical change of 2. So we would represent the component form as 3, 2. Now it says sketch b, 3b, and 1/2 b. So we'll do this in a couple different colors here. B just means that it doesn't have to be on this coordinate plane anymore. It can just be in space, right? So if I know the components, if I were to redraw this, I would just anywhere in space draw a vector that goes 3 units to the right and 2 units up, and making sure that my direction is correct. For 3b, now I'm doing the same thing, but I'm going to multiply 3 into each of the components. So the vector 3b is going to have the components 9, 6. So again, if I start this in space, I'm going to go 9 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6 units up, and draw as straight of a line as I can, which gives me 9, 6. That's 3 times the b vector. And then lastly, we got 1/2 b, which again, I'm taking my original components here and multiplying each of those by 1/2. So 1/2 of vector b would be 1.5, 1. So if I start in a random spot in space, I go 1.5 to the right, 1 up. And what we should kind of notice about this, if I drew my lines straight enough, you would kind of recognize that all of these are going to be parallel because they all have the same direction here. Now, right, a unit vector has the same direction as b. To do that, I'm going to go ahead and find the magnitude first. And so in this case, when I am going to find the unit vector, I'm going to go ahead and find the magnitude and then divide each of the terms by that. So I'll use my original vector b to do that. And I'm going to, again, we have a right triangle here of 3 and 2. So to find the magnitude, I'm going to use Pythagorean theorem. So 3 squared plus 2 squared equals my magnitude squared. So that's 9 plus 4, 13 equals the magnitude squared. I take the square root of both sides. So the magnitude of vector b is equal to the square root of 13. Then I'm going to take my original components again, which is 3, 2, and I'm going to divide those. So we got 3, 2. I'm going to divide those by the square root of 13. And because we don't normally like to have square roots in the denominator, I'm going to multiply the top and the bottom by square root of 13 for each of those components. So getting a little bit ugly here, but our final components of our unit vector that has the same direction is going to be 3 root 13 over 13 and 2 root 13 over 13. So there's a unit vector that has the same direction as vector b.